Okay, so these are the properties of the definite integrals. Okay, suppose f is a continuous function in an interval that contains points a, b, c. Okay, then this is true. Now this is, so basically if you flip the limits of the integral, then the sign of the integral changes. Can you prove it? Can you tell me what is the left hand side? Integral a b fx dx, by definition capital F of b minus capital F of a, right? And what is the right hand side? Minus of capital F of a minus f of b. Obviously they are equal. Okay, I'm just very easy proofs. Okay, what about the second one? I mean, that's also obvious, right? Yeah, so I mean, you can use the area interpretation, otherwise you can use the definition. What is integral of a to a fx dx? It is capital F of a minus capital F of a, which is 0. Okay, right? Yes. What about the third one? Well, that's just going to follow straight from the similar property for the indefinite integral. Okay, so you can take the alpha out. Is that clear? Okay, what about the next one? Okay, how do you prove the next one? What is the left hand side in terms of capital F? F of b minus f of a is equal to f of c minus f of a plus f of b minus f of c. So what are we going to get? F of b minus f of a. Okay, so this is actually very useful. I mean, even though you think that it's kind of straightforward, but this actually has lots of applications. If you want to find integral of a particular function, which is, let's say, piecewise linear, which you can come across, okay, let's say mod function or something like that, then you might want to split the problem, finding an integral, okay, and then solve the integral in for one part and solve it for the other part and then add them up. Are you getting my point? Okay, so let's do one problem. Okay, great. Okay, so suppose fx is absolute value of x minus 1. It's a non-negative function, continuous, and I want to find integral of absolute value of x minus 1 dx from 0 to 2. Let's first break it into 2 and then do it, and then I'll tell you one quick way to do it. Okay, just by looking at it, and you can do it. Okay, just by plotting the graph. Okay, is that fine? So what is this? What is this integral? Well, absolute value of x minus 1 takes value 1 minus x when x is less than 1, and it takes value x minus 1 when x is greater than 1. Do you agree? Okay, so what I can do is I can split it into two pieces. From 0 to 1, I'll be integrating 1 minus x, and then from 1 to 2, I'll be integrating x minus 1. Okay, so what is this integral? Yeah, so this is x minus x squared by 2. I can ignore the constant, as I've just told you, because it's just not going to make any difference. Okay, and then plus x squared by 2 minus x. Okay, yes. So what are we going to get? What is this? 1 minus half plus 4 by 2 minus 2, and then minus half plus 1, right? So what are we going to get? Just check this. This will cancel with this, and then you have 2 minus 1, which is 1, right? Okay, now let's do this through picture. Okay, how is the graph of absolute value of x minus 1 going to look? It's v, and where is this bottom of the v? Huh? At x equal to 1. Okay, that's right. Okay, you want to integrate it from 0 to 2. It's a non-negative function, so it's the area. Non-negative function, it's equivalent to area. The definite integral is equivalent to area. So you know how to find the area, right? This is a triangle. This is a triangle. both have slope 1. These segments have slope 1. So this is 1. This height is also 1. So what is the area of this triangle? Half. What is the area of this triangle? Half plus half is, that's it. Okay, so whichever way you like, you can use it. Okay, and then, okay, but just be careful, when you are using the area. Okay, because it's the definite integral, which is not always the area, because if it's non-negative, then it's fine. Okay, but if it is not non-negative, then it is not fine. And also, let's say if I'll ask you 2 to 0. Yeah, exactly, it will be -1. Okay, so be a little careful, like, so don't just say that it is 1, because that's wrong. Because if you flip the uh, limits, it gets multiplied by -1, right? So if I'll ask you what is the, if I'll ask you what is the area, then give me the area. If I'll ask you what is a definite integral, give me the value of the definite integral and nothing else. Okay, which can be negative, positive. So you have to keep these things in mind. Is that clear? Yes. Okay. Any questions? Yes. Because it's just going to be easier to handle this if I take it from 0 to 1 and then 1 to 2, because from 0 to 1, if you see, this term is actually 1 minus x when x is between 0 and 1. Okay, and it is x minus 1 when x is between 1 and 2, right? So basically, if you can write it like this, then it's easier to deal with 1 minus x than absolute value of 1 minus x, right? So you can, that's why we can split it, okay, like this. You can also look at the graph and see the same thing. The function is 1 minus x from 0 to 1, and then x minus 1 from 1 to 2. Okay, so you take the definite integral from 0 to 1 of this function, and then from 1 to 2 of this function, and then add them up. So you will get, using this equality, you will get the value of the integral. Okay.